Let's have a look at, this is Theta, the Theta textbook. So this is for year 12, and I've been asked to do 2204. We're looking at question 1a, b, and presumably c as well. And it says find fx, that is the function in each of these cases, by anti-differentiating and calculating the constant of integration. So nice and straightforward. So we've got an already differentiated equation here. So we had the original equation, it's been differentiated, and we've got an actual point on here. We know that when x is 4, the function, or if you like, y, will equal 7. And the same is true for the other ones as well. For this particular differential equation, if it's put into the original equation, when x is 0, y is 10. Here, when x is -2, y will be -1. And that's all that means. So let's just go through and do each one and see how we go. So first of all, let's state the first problem. Here it is. And I'll do these separately and write them out in detail so I can talk through each one rather than hurrying them. So here is 1a. And we've got f prime x is equal to 2x minus 3. So that's the differential equation. And what we're wanting to do is to find the original equation. So we're going to anti-differentiate this. So that implies that f of x will be 2x minus 3 with an extra, with the increase in powers. So this will have x, moment that's really x to the 1, so it will now become x to the 2 and divided by the new power. This is really x to the 0, which will now, of course, become x to the 1 and divided by that new power. Plus, of course, we're going to add c, the constant of integration. And this compensates for the fact that when this equation, whatever it is, was originally differentiated, we lost the c term. We lost any integer that was just tagged on the end there. All right, so now let's tidy this up. 2 divided by 2, of course, is 1, leaving me, this implies that we've got fx is equal to x squared minus 3x plus c. However, we also know that f of 4, here it is, f of 4 is equal to, and I'll just make sure I can't see what I'm doing here, f of 4 is equal to 7, we were told. So if I put 4 in there, that is 4 in there and 4 in there, this thing here is equal to 7. So I'm actually just going to write it like that. So this implies that 7, that's 7, is equal to, and I make all of these a 4. So I've got brackets of 4 in there, squared, minus 3, brackets of 4 in there, plus c. So now we're going to solve for c. So we've got 7 is equal to, well, 4 squared is 16. Negative 3 fourths are 12, negative 12, plus c. Well, 16 minus 12 is going to be 4. So I'm just going to cross these out and put a 4 there. So I've got 7, and I'm going to subtract 4 from both sides. There it is. Minus 4 is equal to c. So c is equal to 3. Now we found that's the constant of integration. So now we're going to put that back into the original. Here is the original equation. There it is right there. And we now have a value for c. So I'm just going to rewrite that now. Therefore, I'll put, f of x is equal to x squared minus 3x plus, and there's our c value right there. So I'm just going to put that on the end. And that is our answer. Hope that makes sense.